Welcome to series of database management system video lectures. Today we'll be discussing about Unit 3, Topic 7, that is concurrency control schemes. Now, what do we mean by concurrency control schemes? So these are the protocols or the procedures which helps us to manage the execution of concurrent transactions in order to overcome the conflicts and to maintain consistency in the database. So we have two different types of concurrency control techniques. The first one is pessimistic concurrency control and the second one is optimistic concurrency control. In pessimistic concurrency control, we assume that conflicts will definitely happen or occur and we will try to prevent them by locking the data items. So we apply locking mechanisms on this pessimistic concurrency control system in order to handle the conflicts. The second technique is optimistic concurrency control, in which we assume that the conflicts will happen very rarely and we need not prevent it and we resolve it as and then when they occur. So instead of preventing them, we try to handle whenever it will happen. So we have two different types of techniques for pessimistic concurrency control. The first one is log-based concurrency control protocol, and the second one is timestamp-based concurrency control protocol. And in optimistic concurrency control protocol, we have a multi-version concurrency control protocol, and the second one is validation concurrency control protocol. So we just start with log-based concurrency control protocol. Now, for log-based concurrency control protocol, we have two different types of logging mechanism. The first one is shared log, and the second one is exclusive log. As the name itself tells that shared log can be used, which can be shared by multiple number of data members. Let us take a schedule. In this schedule, we have T1 transaction and T2 transaction. Now, we have a data member A here. Now, I wanted to read the content of A. When I wanted to simply read the content of A, I need a shareable log. So, shareable log allows you to access to the data and it can be allowed by multiple number of transactions to access to it. Now, when I have applied shareable log upon data member A by T1 transaction to acquire, if T2 transaction also later wants to perform a read operation upon data member A, then you can do parallelly with respect to two different transactions. So, shareable log can be used in such a way that any number of transactions can access to this data member. As we are performing read operation, you can share it. Right? Now, let us say that I wanted to perform a write operation upon data member A. So, write operation is nothing but manipulating the data value at A variable. So, this may not be achieved when you use a shareable log. So, instead, you should apply an exclusive log upon data member A. Only then we will be able to perform write operation upon data member A. Now, if we are using exclusive log upon data member A, only one transaction can access it. If any other transaction is requested to act upon data member A, it is not going to be allowed. So, that is the specialty of exclusive log. So, mutually exclusive, which means that only one particular operation can be done with that data member. So now, with respect to this schedule, if you wanted to perform only read operations upon a data member, then it is suggestible that we can apply a shareable log. If you wanted to perform a manipulation upon the data member, then exclusive log is suggestible so that you can perform any operations, and only after that you can unlock the exclusive log upon data member A. Okay. Now, when this log is released, then T2 can obtain. If T2 wanted to perform a write operation upon data member A, then it can be released and it will allow to perform on T2. Right? So this is how a logging mechanism helps us to protect the variable data without manipulations. Now, while dealing with this, we have grant and request compatible matrix or a table which helps us to understand better about how and which type of log can be allowed. So this can be represented by using a two-dimensional table. So wherein here we go with a grant, here we go with request. Now we have shareable and exclusive log, shareable and exclusive log. Now, when we have already granted shareable log upon a data member, can we request for another shareable log upon the same data member? Yes, it can be allowed. Now, the second point is that when already we have obtained shareable log upon a data member A, and can we request for exclusive log upon the data member? No, it is not possible. Now, the second scenario, wherein we have already obtained exclusive log upon data member A. Now, can we request for shareable log upon that data member? No, it is not possible. And then exclusive log is already obtained upon data member A. Can we apply another exclusive log upon the data member? No, it cannot be allowed. So, by following this grant and request compatible matrix, we will be able to know that when and which type of log can be allowed. Now, in this scenario, we have taken only data member A. Right? We have taken data member A. Let us say that if we have taken two data members and continuing with the same schedule. Now, here, as part of T2 transaction, if I have requested for, I wanted to perform read operation upon B variable and write operation upon B variable, then which type of log can be suggestible here? As we need to perform both the operations, then exclusive log can be suggestible. So, I can request for exclusive log upon data member B. So, now this can be granted because already we have acquired exclusive log upon data member A, and this is a different data member. So that's the reason this log can be granted. So there will not be any conflict here as both the transaction involves two different data members. So no issue in allowing exclusive log upon data member B, right? So it continues and this also continues. Now when the T2 transaction has requested for writing upon data member A, and here as part of T1 transaction, we have already obtained exclusive log upon data member A, but it was not yet released. So this cannot be granted because unless you don't release exclusive log upon data member A, this may not be given to the transaction T2, right? So without unlocking, you cannot obtain log upon the same data member. So this is the rule which we need to follow here to deal with the different types of locking mechanisms. Now, while dealing with this shareable and then exclusive log upon data members, we have few set of drawbacks. The first one is that we may not be able to perform serialization. Second point is that we may encounter with deadlock scenario. Third point is that we will not be able to recover. That means irrecoverability. And the fourth one is starvation. So all these are the various drawbacks which may come across while dealing with the shareable and exclusive log upon any data member. Let us look at the first one, that is serialization. So how can we not be able to get a serialization schedule when we apply shareable as well as exclusive lock. So let us take that there are two transactions, T1 and T2. Now I wanted to perform read operation upon data member A and write operation upon data member A. So then I need exclusive lock which can be applied upon data member A, right? So now this can be granted as we have initialized the transactions just now. So there were no other locks which have been applied, right? Now T2 transaction at later point of time wanted to perform a read operation upon data member A. Now can we get a shareable lock with respect to the operation as it involves only read operation? It is suggestible that you can apply shareable lock upon data member A. Now look at this scenario. Already we have acquired exclusive lock upon data member A. So we cannot get, you cannot apply a shareable lock. As for the matrix which we have discussed, already you have taken exclusive lock upon data member. Can we obtain shareable lock upon the data member? No, it cannot be achieved. So that's the reason you cannot be granted to acquire shareable lock upon the data member. Now, if we wanted to perform even write operation, then you cannot grant this. So in this case, I need to wait. This T2 transaction should wait till T1 transaction has unlocked the exclusive lock upon data member A. Only then T2 can finish its task. This is the scenario of one schedule. Let us take another schedule wherein again we involve with two transactions upon same single data member. Now I wanted to perform a read operation upon A variable, write operation upon A variable, and a read operation upon A variable by T2 transaction. Now when we compare these set of operations, we can very easily see that here as T1 has started first, I can apply exclusive lock upon data member A, right? And here you can request for shareable lock upon data member A, right? So now you are reading the data member A and you are modifying the content of variable A. The modified or updated value is being read. Let us say that we are unlocking this data member here. After unlocking, you will be able to acquire a shareable lock upon data member A. This modified value of A is read by T2 transaction and the same thing has been read, and now at later point of time, you have committed. That means you are storing the final result into the database. Now, T1 transaction was continuing further and it has failed at certain point of time, right? So in that case, without committing here, it has failed at some point of time. Now, what we need to do in order to recover, we need to perform a rollback operation. Now, to do this rollback operation, we start from here, unlocking upon data member A and then writing, modifying the operation of A. Now, during unlocking of it, whatever the manipulation to the data member A, even this should also be rolled back, right? So while rolling back of this, whatever the data value which has been changed here, and the same thing has been read by some other transaction. So I need to even roll back all the series of operations in transaction T2, right? So this is called as cascading rollback. So cascading rollback involves that sequentially rollbacking one transaction from the other transaction. So now here we need to even roll back T2 transaction as the dirty read has been happened here, right? But then when you wanted to perform this rollbacking operation, T2 transaction has already committed. So now I will not be able to roll back here. Rollback fails here because we have freezed the data values in the database and it cannot be recovered. That means irrecoverability. So this is the second issue which we have mentioned here. Irrecoverability is done using shared and then exclusive lock. So this can be taken as one of the drawback of share and exclusive locking mechanism. Now the first one is, if this sort of schedule is there, can we convert this into a serial schedule or not, serializable schedule or not? What is the definition of serializable schedule? You can convert all the group of operations of T1 and T2 in such a way that there will not be any conflicts that arises and you can smoothly conduct T1 transactions and T2 transactions, right? So as it involves commit and rollbacking operations, you will not be able to convert the whole schedule into a serializable schedule. So that's the reason the first problem is you cannot serialize the given schedule when we have applied shareable and then exclusive lock mechanism. Now the third schedule, look at the third schedule. Again, we are involving T1 and then T2 transactions here. Now I wanted to perform a read operation upon data member A and write operation upon data member A, right? And now as part of T2 transaction, I wanted to perform write operation upon data member A. Now as it involves these two transactions and T2 has started first, I need to use an exclusive lock upon data member A, right? Now, as part of T2 transaction, it has to wait till it finished T1 transaction because already exclusive lock has been obtained by T1 upon data member A. So this cannot be granted because you are attempting to perform write operation upon data member, which needs exclusive lock upon data member, which cannot be given at this point of time. Now, if read operation upon data member P is done by T2 transaction and write operation upon data member P, yes, this can be allowed. So here it will allow exclusive lock upon data member P. So this can be granted because so far no locks have been acquired upon data member P by any other transactions. So that's how it will continue these two operations. Now during the processing of T1 transaction, it wants to perform a read operation upon data member B. So only read operation needs to be performed. So then I need to apply a shareable lock upon data member B, right? So in this context, as already T2 transaction has obtained exclusive lock upon B data member, you cannot get a shareable lock upon data member B. So this fails here. Now to finish T1 transaction, T1 is waiting for P data member to be read. And T2 transaction is waiting for accessing to data member A, which is holded by T1, and the P data member has to be read by T1, which was holded by T2 transaction. So now this is waiting for this, and this is waiting for this. So this scenario is called as a deadlock scenario. Unless one particular transaction has not released a lock upon a data member, the other transaction may not continue further. And to finish the execution of that particular transaction, it is waiting for the other transaction to release. So this is called as a deadlock scenario. So this is again another drawback going with shareable and exclusive locking mechanism. And finally, you have starvation. Now let us take other set of schedule wherein I wanted to perform a read operation upon data member A. And so in that case, I can simply go with shareable lock upon data member A, right? At later point of time, I wanted to perform read operation upon data member A. So can I get a shareable lock upon this data member? Yes, because as it is a shareable lock, shared upon shareable can be accessible by the T2 transaction as it involves the same. Now, at later point of time, I wanted to perform write operation upon data member A. So this may not be sufficient enough. So that's the reason exclusive lock upon data member A is needed, right? So now, from T2 transaction, when you wanted to perform a read operation upon data member A, which may not be happened because already you have given this is granted, that is exclusive lock upon A is already granted, and you cannot acquire a shareable lock upon data member A. So it keeps on waiting, and then now At T3 transaction, if again shareable lock upon data member A is required to perform read operation upon data member A, it will also be waiting for the exclusive lock to be released by T1 transaction. Now, T4 transaction at later point of time wanted to perform a read operation upon data member A. It may also require a shareable lock upon data member A, right? So it will also wait because it cannot be granted, and it cannot be granted as exclusive lock upon data member A was already given for T1 transaction. Now, here we are unlocking exclusive lock upon data member A. So when we do that, T2 transaction will obtain the shareable lock upon data member A, and then it can also acquire shareable lock upon data member A by T3 as well as T4. Right? So now, unless all these operations are done, are done only if exclusive lock upon data member A is released. Unlocking of it will helps us to perform these operations. Assume that this unlocking was not yet done, right? It keeps on waiting for it, right? Unless this lock was not shared, was not released, it will not be able to allow the other operations. If it was unlocked, then all the other continuous waiting transactions will be able to perform. So which means that T2 will wait, T3 will wait, and then T4 will wait. But then up to certain limit time only this will wait. Whereas in deadlock scenario, it is infinite wait. Infinite waiting time is called as deadlock scenario, and then waiting for a limited amount of time is called as starvation, right? So these are the technical problems that encounters while dealing with shareable and then exclusive lock upon the data members while performing concurrent transactions. As we have already discussed about shareable lock and exclusive lock upon data members, due to the mentioned drawbacks, we need to visit two-phase locking protocol. The next type of locking protocol or locking mechanism is two-phase locking protocol, which is also abbreviated as 2PL locking protocol. So here we have two different scenarios or the phases. The first one is growing phase, and the second one is the shrinking phase. In growing phase, we continuously obtain the locks upon data members, whereas in shrinking phase, we release the locks one after the other, right? So let us go with an example to understand better about this. So we have schedule S, wherein T1 and T2 transactions are involved. So in T1 transaction, I wanted to perform read operation upon data member A, write operation upon data member A. So to do this operations, I definitely need exclusive lock upon data member A, right? So when you have acquired exclusive lock upon data member A, now at later point of time, T2 transaction wanted to perform read operation upon data member A, you cannot perform this operation. It cannot be granted. To do this operation, we need a shareable lock upon data member A as it involves only read operation. So it cannot be granted. It cannot be granted because we have already obtained exclusive lock upon data member A by transaction T1. So when you have acquired the lock, then we call it that we have started growing phase of transaction T1. Now, I wanted to perform read operation upon data member B by T1 transaction. So I need a shareable lock upon data member B as it involves only read operation. At later point of time, T2 transaction wanted to perform read operation upon B and write operation upon B. So to do this operation, we need exclusive lock upon B data member, which was not already done by T1 transaction. So this can be obtained. Can we get this lock, that is shareable lock? When we got shareable lock, can we obtain exclusive lock? When we got shareable lock, can we obtain exclusive lock? No. So this may not be granted also. So now in this context, we just try to obtain. So even this cannot be done. So what we can do is that you have obtained exclusive lock upon A data member, shareable lock upon B data member. So this means that you are obtaining all different locks upon different data members. So that's how it is called as a growing phase. Now, once the operation upon data member B is done, that is a shareable lock. So I am releasing shareable lock upon B data member. So that's how exclusive lock upon data member P at later point of time can be granted as it was of no locks which have been applied, you can get it. So now, as soon as we have started unlocking, at this point of time, you are entering into a shrinking phase. So shrinking phase tells us that you are going to release all the types of locks and you are not going to get any other locks, right? So after unlocking shareable lock upon B data member, let us say that you are requesting for exclusive lock upon data member B. Right? You cannot. This particular operation cannot be granted, which is absolutely wrong because when you are in shrinking phase, you need to just perform unlocking of various other locks which have been previously obtained, but you cannot request for any more types of locks. Why the sort of mechanism which has been applied here is nothing but in order to overcome with a starvation as well as a deadlock, we will be able to perform this operation. So starvation, you need not wait continuously for one particular data item, right? And deadlock can also be resolved unless you don't release a set of locks. The other set of operations may not be fulfilled, right? So to resolve these two issues, two-phase locking protocol helps us better, right? So now you'll be in shrinking phase, and then you need to release even the exclusive lock. You need to unlock exclusive lock upon data member A as well. You need to release. So all this is called as shrinking phase, and the above part is called as growing phase, wherein you are continuously obtaining locks, and from here point of time you are releasing the locks. As soon as we release the locks, the other waiting transactions can acquire the locks as desired. Right? Now, at this point, whatever the unlocking mechanism that we are doing, what was the last operation which has been performed by the transaction is called as lock points. So based upon lock point, you will be able to say whether can we convert the given schedule into a serializable schedule or not. Right? So what is happening here? T1 has started first and T2 is continuing, and then later again T1 is continuing. So this is called as concurrent transactions, and which will never be converted into a serializable schedule. In serializable schedule, we are trying to overcome with the context. So either T1 should start first and T2 should end, or T2 should start first and then next T1 should finish its operations. But then it should not create any kind of loops like this, right? When we are forming a loop, which means that you will not be able to serialize the given schedule. So to overcome with it, two-phase locking protocol helps us better to convert any given schedule into a serializable schedule. So that can be obtained, that can be identified by getting the lock point. What is the lock point for a given schedule? That need to be identified. Based upon that, you will be able to decide whether it can be serializable or not. So with this, the point where from you are going to decide how to unlock this right? So here, before you unlock any sort of operations, any sort of locking mechanisms, if it was committed, then you cannot roll back it. That means it cannot be recoverable. If it was not committed, then you can recover. So while recovering also, if read operation and write operation was done, and the same write operation value is read by T2 transaction, then again you need to perform a cascading rollbacking mechanism. So that's the reason we need to ensure whether have we committed or not. If it was committed, then we need to even roll back the other set of operations. If commit was issued, the schedule cannot be recovered. That means irrecoverable. Whereas you will be able to convert this given schedule into serializable schedule if we don't use a commit statement. So we have at least resolved few sets of drawbacks which have been encountered by shareable and exclusive locking mechanism. So now either T1 should start and finish T2, or T2 should start and T1 should finish. Only then we can say that the schedule can be serializable without any conflicts. But then by looking at this schedule, we may not be able to achieve this sort of thing because T1 has started first and T2 has continued. It has started and T1 was continued. So this is going to be irrecoverable schedule. But then with the help of this 2PL, that is a two-phase locking protocol mechanism, with the help of obtaining multiple locks upon different data members in growing phase, can be released in shrinking phase. With the help of this in shrinking phase, if you have started unlocking one particular lock, you need to release all the other subsequent locks which have been obtained by other data members. So now it can be up to some extent it can be serializable. So how? By going with the lock points, you will be able to decide what set of operations can be serialized further, so that putting all T2 together and T1 together, right? And this can be done only by performing commit operation. Okay. Yes. Now in continuing further, with the help of this two-phase locking protocols, you are going to ensure a serializable schedule, but the other set of drawbacks remains the same. Only the advantage is that you can perform serializable, you can convert any given schedule into serializable schedule, and other drawbacks remains the same, that is irrecoverability, and then deadlock, and then starvation, and then cascading rollbacks. So all these remains the same. So now, in order to overcome with this set of operations, we have other types of locking protocols, that is strict two-phase locking protocol, and the second one is rigorous two-phase locking protocol, and the third one is conservative two-phase locking protocol. So these are the three different variations that have been developed such that it can even provide the solution for the drawbacks which we have encountered. So what is happening with the strict two-phase locking protocol here? So when we compare with this particular schedule, before you release the lock, you need to definitely perform commits, or it has to either abort. So when we abort or commit, only then we will be able to perform rollback. If committed, you will not be able to perform rollback, right? So cascading rollback issue is going to be resolved when we perform commit operation. So one particular drawback was been resolved by that. Second point is that you need to resolve the deadlock scenario as soon as you perform this commit operation, and then after that you are entering into a shrinking phase, or you need to release all the other associated locks. So which is going to benefit the other waiting transactions. It need not wait for infinite time. So the deadlock issue is also going to be resolved. And the third one is starvation. So as you are entering into growing as well as a shrinking phase, you need to release all the locks. So that's how no other transactions are going to be waited till you release the locks, right? So whether it could be a finite or infinite time, which can also be removed completely with the help of this strict two-phase locking protocol. Okay. So the rigorous 2P. The only difference between strict and rigorous is that in strict 2PL, only exclusive locks can be released, right? Either by committing or by aborting. Whereas rigorous, even shareable locks as well as exclusive locks have to be removed either by committing or by aborting. So rigorous will be much more stricter than 2PL. Okay. So when you look at this, the first level of constraints will be basic transaction processing control mechanism. Okay. Basic protocol. And then the next level will be 2PL. And the next level will be strict. Okay. So this is how the levels of security and the way how it is going to be more strict in terms of releasing the third one is conservative. So in this conservative, we first obtain all the locks upon all the data members which you are going to use, right? So that you will perform all the operations. T1 transactions will perform all the operations upon A, B, C, and then it will release all the locks. It will release all the locks. So that T2 will not hold any other data member and it will not wait for some other. So by doing that, so you are going to remove deadlock scenario, starvation, and you need not recover from any other fault that has been occurred, and we need not perform cascading rollbacks, right? So these issues have been resolved by going with the different variations of 2PL mechanisms, right? So this will be the end of locking mechanisms or locking protocols in database management system.